Our lesson for today will be looking at Physics 1505. We are still busy with Newton's second law. Practice questions. Let us start. This is the question for today. The question says 2 crates, 4 kg and 6 kg respectively are connected with a thin, inextensible rope, and a force of 89 Newton is applied to the right. The frictional force on the 4 kg and 6 kg are 19.6 Newton and 29.4 Newton respectively. This simply means that this kinetic friction goes to this one, then this kinetic friction is for the 6 kg. The question says calculate the acceleration of the crates. Second question, calculate the magnitude of the tension T in the rope that connects the boxes. Now, as usual, we need a picture form of this. So we have the first box, which is 4 kg. We have the second box, which is 6 kg. We have the 6 kg and the 4 kg. They're both connected by a string. Then there's applied force, this direction. The magnitude is 89 newtons. It's actually this one. Then we are given that the kinetic friction experienced by the 6 kg is 29.4 newtons, and the kinetic friction experienced by this is 19.6. So basically we know that we have normal force and Fg. But before we can start calculating, by the way, the displacement of the system is to the right. So the question says calculate the acceleration of the 2 crates. Before we do that, let us draw a free body diagram. I normally say we draw a set of free body diagram. We start by the free body diagram of the forces acting on the object. This is the 4 kg. Then for the 6 kg, by the way, 4 kg we have normal force, we have kinetic friction, we have Fg, and we have tension. It is moving due to tension. We are not applying any force to it. So for the 6 kg, we have normal force, we have Fg, we have tension, we have kinetic friction, and then we have force applied. These are the free body diagrams of the forces acting on the object. Now let us draw free body diagrams of the forces which does work on the object. So this is the displacement, this direction. Then we can see that we only have 2 forces which are parallel to the displacement. We have kinetic friction and we have tension. Looking at our next object, if this is the displacement, we have force applied, which is parallel to the displacement. We have tension, we have kinetic friction. So these are the forces that will basically take part in the F net is equals to MA. Now we are starting to answer this question, which is the first question. We need the acceleration of the blocks. So for the 4 kg, we need to generate an equation for 4 kg. The first thing that we have to do, we write the equation F net is equals to MA. Then from there, how many forces that does work. And before we continue, we are going to take the motion of, or the displacement of the object as positive. So we are going to take right as positive, then left will be negative. Let us quickly go back. So we can see that our Fk will be negative, our tension will be positive. So we have tension minus Fk equals to Ma. And then we don't have tension. And then Fk we are given as 19.6 equals to, the mass is 4. Then we have acceleration here. Now let us go ahead and make T the subject of the formula. So we are going to transpose 19.6 the other side. So we are going to have T, it's equals to 4a plus 19.6. Then we're going to say this is equation 1. Then going to our second object, F net is equals to Ma. How many forces does work? We have 3. So it will be positive, negative, and negative. So we have force applied minus tension minus Fk, it's equals to Ma. Then our force applied is given as 89 minus tension minus the kinetic friction is 29.4 equals to, the mass is 6a. Then let us go ahead and make T the subject of the formula also. So we are going to take this T to the other side and then bring the 6a to the side. So we are going to have T, it's equals to negative 6a. Then we can quickly solve this. 89 minus 24.4, we get positive 59.6. Then this will be our equation number 2. Now once you are done with these steps whereby we generate the two equations, what we're going to do now, we are going to equate, since both of them have the subject of the formula as T. So we are going to say equation 1 is equals to equation 2. So this is our equation 1, 4a plus 19.6, it's equals to negative 6a plus 59.6. Now let us take all the terms with a one side, take all the terms without a the other side. So we are going to transpose this to this side, take this one to this side. So we have 4a plus 6a, it's equals to 59.6 minus 19.6. So we have 10a equals to 59.6 minus 19.6, we are going to get 40. And then we divide both sides by 10. Then we get that our a is equals to 4 meters per second squared. Since it's positive, it means to the right. So this is our acceleration of the system. So we get 4 meters per second squared to the right. Now the next question, it says calculate the magnitude of the tension T in the rope that connects the boxes. It's either we can use this equation or this one. Since we have the value of A, we can just substitute it here and find our T. So doing so, we have T, it's equals to negative 6, where we see A, we substitute by 4, plus 59.6. And then we get that our tension, it's equals to 35.6 newtons. Now since it's positive, for this one it will be to the right. By the way, I think, or the question is saying the magnitude, meaning that we don't need the direction, just need the magnitude, of which is this one. Now that's it for this lesson video. This is Wahula SJ. Thank you very much.